In this class, we are going to discuss about the single phase AC voltage controller with RL load. The firing angle should be more than the load angle theta, where theta equal to omega L by R. Suppose if the load angle is 10 degrees, the firing angle should be more than the 10 degrees. Nothing but you have to maintain the 15 degrees, 12 degrees and 20 degrees. Then only the circuit is giving a regulated RMS output voltage to the load. To explain the circuit operation, again we have taken the two cycles of the input voltage, pi, 2 pi, 3 pi, 4 pi. So whenever the SCR1 is forward bias, apply the triggering voltage to the T1 with the delay angle alpha. Here we assume that this firing angle should be greater than the load angle. So whenever the T2 is forward bias, apply the triggering voltage to the T2. That is happened during the negative cycle of the input voltage with the same delay angle. Now we are going to see the circuit operation. At alpha, the T1 is on. Once the T1 is on, the load voltage follows the input voltage up to pi. After pi also, the T1 is forced to conduct. So here you can find the negative voltage. When the load is subjected to the positive voltage, load current will be increased to the maximum value. When the load is subjected to the negative voltage, the load current is come to the zero at angle beta. So at angle beta, the T1 will be turned off. Between beta to pi plus alpha, no device is connecting circuit, the output voltage becomes a 0. At pi plus alpha, the T2 is on. Once the T2 is on, again the load voltage equal to source voltage, that is equal to the negative from pi plus alpha. Again after 2 pi, the T2 will be forced to conduct because of inductance. Here we can find the positive voltage. Again at this point T2 will be naturally turns off. Between this point to 2 pi plus alpha, again no device is conducting circuit. The same circuit operation, we complete the waveform. So because of this notch only, the output voltage waveform will be differ from the input voltage waveform, which gives the regulated AC voltage. This is possible only if you maintain the firing angle greater than the load angle with the RL load. If you draw the current waveform, you start the current waveform at this point, increase to the maximum value, bring to the 0 at angle beta. Again here, start the current waveform here, increase to maximum value. When the load is subject to positive voltage, again you bring this current to the 0. So output voltage waveform is also the AC voltage and output current also the alternating current. Now we are going to find out the RMS output voltage. From alpha to beta, whatever the waveform is there, the same waveform is repeating. Now the base length becomes a pi. To find the RMS output voltage, I have to calculate the average value of the square of this curve. So the RMS output voltage is equal to 1 by pi integral alpha to beta Vm sin omega t whole square d omega t. Vm square take outside, alpha to beta 1 minus cos 2 omega t divided by 2 d omega t whole power 1 by 2. Now we complete this integration. We are getting the Vm by root 2 pi beta minus alpha by 2 minus sin 2 alpha by 4 power 1 by 2. Take 2 common here. So finally we are getting the Vm by 2 root pi beta minus alpha plus sin 2 alpha minus sin 2 beta by 2. So by using this formula you can calculate the RMS output voltage of a AC voltage controller with RL load. Here ambiguity is the how do you calculate this beta value, that we are going to see in the next coming classes. Thank you very much for watching this video.